So this is the 9295 quiz review. We are going to have a quiz tomorrow over those sections that will look very similar to what you see here. So use this as a study guide. Let's start with our first problem here. It says to find the exact value of the following items. If the cosine of theta is -3/5 and we are in quadrant 2. So the first thing I want you to notice is what quadrant you're in. Now let's remind you how that works. If you're in quadrant 1, you're there. Quadrant 2, you're there. You're quadrant 3, you're there. Quadrant 4, you're there. I think it kind of looks like a very strange triangular butterfly. You always connect to the origin, so if that helps you. So the first thing I want you to do if we're in quadrant 2 is put a point in quadrant 2, connect it to the origin, and make your triangle. Your theta is always the angle closest to the origin. Now, remember cosine, we're going to go back to SOHCAHTOA. Cosine is adjacent over hypotenuse. Because it's going to the left, your adjacent is negative, your opposite is positive, and your hypotenuse is always going to be positive, okay? So now from there, you need to use the Pythagorean theorem to find our missing side. So we know that y squared plus -3 squared has to equal 5 squared, or y squared would equal 16, or y is plus or minus 4. We know it's positive because in the second quadrant, the y is positive. So anytime you see these, first step, draw your triangle. Second step, fill out your triangle. Any missing sides can be completed using your Pythagorean theorem. Now that we have that, the triangle answers only the questions at first that consider theta. So we can only answer A and B with SOHCAHTOA. So let's do that. For A, the sine would be +4/5. The tangent would be either sine over cosine will work, or you can do opposite over adjacent, and we get -4/3. Now, for the sine of 2 theta, the cosine of 2 theta, and the tangent 2 theta, you must use the formulas that are up on the chalkboard to your left. They will be there for the quiz. So our sine of 2 theta formula, let's start there. The sine of 2 theta is 2 sine of theta cosine of theta. And we're just going to fill in the information that we used that we found in parts A and B, or that we were given. We found that the sine was 4/5 and that the cosine was -3/5. Now, to do this in a good manner, what my suggestion would be is deal with the signs first. A positive times a positive times a negative is a negative. Now let's deal with our numerators. Now remember, this 2 is over 1. Now you are welcome to use a calculator, but I want the exact value in fraction form. So, you can use a calculator for that, but just multiply tops with tops and bottoms with bottoms. If you multiply 2 times 4 times -3, you get -24. And then 1 times 5 times 5 is 25. Now, a good rule of thumb for this is the answer for the sine of 2 theta and the cosine of 2 theta should be a proper fraction that is either positive or negative. The 24/25 is a proper fraction, so we're good to go. Now let's move on to D. For D, there are 3 different formula options. Each one will get you the exact same answer. You decide which one to use. What I like to do is I like to see which one, what did they give us initially? They gave us the cosine. So in case I messed up my sine, I like to use the formula that only contains what I was given, the cosine. So I'm just going to use 2 cosine squared theta minus 1. Now, if you happen to use any of the other formulas that are up on the board for the cosine of 2 theta, um, go for it. You're going to get the same thing as long as you follow order of operations. So let's stick in our values. That's going to be 2 times the cosine value squared minus 1. Now that requires a little more thinking when we do that. And there is a minus 1 there. I did write it, I promise you that. Oh, there we go. Okay, so there's a delay for some reason. Okay, so now let's concentrate on the order of operations here. So let's put R2 as 2 over 1. To square a fraction, square the top, square the bottom. 2 negatives or something squared is going to become a positive. 3 times 3 is 9. 5 times 5 is 25. Multiply the tops on the first fraction and the bottoms. That would be 18 over 25. And whatever your denominator happens to be, make the one match on top and bottom. So in this case, 25 over 25 for an answer of negative 7 over 25, which is a proper fraction. So that is your answer for the cosine of 2 theta. Yeah. So that is your answer for the cosine of 2 theta. So just watch how you deal with your fractions. So that's that. Now the next formula, on the quiz, am going to ask you to find the sine of 2 theta and the cosine of 2 theta. So I think the easiest method is to just do the sine of 2 theta divided by the cosine of 2 theta. We already found those values anyway. So you're going to put the sine fraction on top over the cosine fraction on the bottom. And then we get to do big C over little c. Now, still in any multiplication or division, deal with what the signs are going to be. 2 negatives are going to make a positive, so we know that's going to be a positive. Now let's just do big C over little c for a moment. I'm going to not do the math. I'm going to show you, okay? On the top, we would get a 24 times a 25. On the bottom, we would get a 7 times a 25. What happens here are the 25s are going to cancel. I want that exact fraction. I want the answer 24 over 7. And go look back at what we got for the sine of 2 theta and the cosine of 2 theta. Do you see how in a way it became the opposite over the adjacent? That isn't by coincidence. It will kind of work its way out that way. Yes. I did the negatives first. I dealt with the negatives first and then the numerical components. If you put up here a negative 24 and a negative 7, you're still going to get a positive anyway. So if you wrote the negatives and then at the last step evaluated what happened to them, sure, that's fine. I kind of just dealt with it. When I do multiplication and division, I tend to think of the math in 2 steps. I deal with the signs, so then I can throw that out and I got that. Never have to deal with the signs again. And then I deal with the numerical components. And it just kind of makes so that you don't forget a sign, or so you can deal with all the signs first and then deal with the things later, or as you go through the process, it will also work its way out. You decide how you do that. Any questions about our first component? That would be from the section related to the double angle formulas, which I believe was 9.3. So that's kind of the only thing you're going to be asked for from 9.3. Now, from 9.1, or 9.2, I'm sorry, we did the sum and difference formulas, and that's what question number 2 and question number 3 are asking. So now let's move on to question 2 and 3. Question 2 and 3 says to find the exact value. I do not want decimal values for these. I want that square root weird answers. So what you're going to do is you're going to find any 2 values on the unit circle that either add up to those things or subtract to 2 things. You might come up with two versions that work that are different than mine. So I'm just showing you the ones that came to my head. So when I see this first one here, I think about that as 45 plus 30. So those are two things that nicely add up to 75. Up on the board are our sum and difference formulas. We want to use the sign plus formula, the sum formula, which you can see the signs there are in that light blue color. So the formula I'm going to use is that the sine of alpha plus beta is the sine of alpha cosine of beta plus the cosine of alpha sine of beta. My alpha is going to be 45, my beta is going to be 30. Let's plop them into the formula. So it's going to be the sine of 45 times the cosine of 30 plus the cosine of 45 times the sine of 30. Now, hopefully the first quadrant is in your brain from the unit circle. And at 45 degrees, the point is square root of 2 over 2, square root of 2 over 2. At 30 degrees, the point is square root of 3 over 2, 1/2. So let's plop in the appropriate information. Remember, our cosine at that particular spot is the x value at that spot. The sine value is the y. So this is going to be square root of 2 over 2. The cosine of 30 is the x value at 30, square root of 3 over 2. Cosine of 45, square root of 2 over 2. Sine of 30 is 1/2. Now, following order of operations, we have to do the multiplications first before we do the addition. To multiply fractions, multiply tops with tops and bottoms with bottoms. So when we do that, we get square root of 6 over 4 plus square root of 2 over 4. And that's pretty much right, but I would suggest what I want is one fraction for your final answer. To add those fractions, we add up the tops in just like a list, and we keep one denominator. So that is an example of a sum formula. Again, the sum formula is up on the board. Use a light blue sign. The difference formulas use the yellows. Okay. Do we have any questions about our first sum or difference formula? Good. And again, those will be up on the board for you, so you don't have to have those memorized. Okay, so number 3 is the cosine of 15. Now, we don't have anything that's quite that small on the unit circle. So that should tell you I just need to subtract 2 things to get 15. So I'm going to think about this as the cosine of, let's do 45 minus 30. We already had those nice points for 45. Remember, 45 was square root of 2 over 2, square root of 2 over 2. And 30 was square root of 3 over 2, 1/2. Okay. So the cosine difference formula, if you look up on the board, you want to use the cosine formula that has a minus sign, so that would be the yellow. So the cosine of alpha minus beta is the cosine of alpha times the cosine of beta plus the sine of alpha sine of beta. So if you look up on the board, the yellow sign in the cosine that starts out as a minus, when you use it in the actual formula, it switches and becomes a plus. Okay, so now let's go ahead and put that in. So if we plop our alphas and betas, this is going to be our alpha, this is going to be our beta. We get the cosine of 45 times the cosine of 30 plus the sine of 45 times the sine of 30. Now, many of our answers are going to look very, very similar. They might have the same exact numbers, but maybe one will have all positives and one might have a plus and a minus, but you're going to see a lot of repeats as far as how these look. Okay, so cosine of 45 square root of 2 over 2. Cosine of 30 is square root of 3 over 2. Sine of 45 square root of 2 over 2. Sine of 30 is 1/2. We get square root of 6 over 2 plus square root of 2 over 2, which is square root of 6 plus square root of 2 over 4. Those are 4s. Those are 4s. Sorry about that. Okay, you might see we got the exact same answer we got. Now, that's not necessarily going to happen on the quiz. Let me describe why. If two angles are complements, add up to 90 degrees, the sine of one will end up being the cosine of the other. It's just, think about in the triangle, if one angle, the opposite, when you think of the perspective from the other angle, it becomes the adjacent. So it only so happens that I chose two that add up to 90. So the sine of one does become the exact value of the cosine of the other. Again, coincidence, that doesn't usually happen. But yeah, we got the same exact answer. Square root of 6 plus square root of 2 all over 4. Okay. Now, as far as section 9.5, that's the only one that we still have to go over. Let's take a look at the problems that we see down here as far as solving on the interval from 0 to 2 pi. So none of these do you have to stick on that plus 2n pi. We're just doing the, what are the answers on the unit circle from 0 to 2 pi. Don't include the 2 pi, just include 0 if you need to. Okay. The ones that are the first 6 there, I would say, are more indicative of what we're going to see on the quiz. So let's just go over and let's start with problem number 1. This is already solved for us. It says the trig function equals, so then you say where on the unit circle is the sine of theta going to equal square root of 2 over 2. So we are looking for what angle will do that. So where on the unit circle is the sine equal to square root of 2 over 2? What angle is going to do that? Well, the sine is positive in the first and second quadrants. Square root of 2 over 2 happens at the 45s. So in the first quadrant, that's pi over 4. In the second quadrant, that's 3 pi over 4. By knowing that unit circle, that is really going to be a helpful thing for you, okay? So make sure tonight you look over that unit circle and make sure you know your unit circle values, okay? Now let's move on to problem number 2. There is a technique for number 2 that we can square both sides, find, do some math to it. We can divide both sides by cosine and get that the tangent equals 1. But let's use some logic. Where is the cosine and the sine the same? That's all that's saying. Where is the cosine and the sine the same? Aren't the cosine and sine the same at the 45s? The ones where both 45s are either positive, positive, or negative, negative. Let's think about what quadrants that happens. That is going to happen at the 45 in the first quadrant. They're both positive, square root of 2 over 2. And the 45 in the third quadrant, which is 5 pi over 4. So again, by knowing your unit circle values, you really are going to have a step up on this quiz, okay? Now, in number 3, it's actually the exact same problem as number 2. Those are exactly the same problem. The tangent is equal to 1 when the sine and the cosine match. Where did that happen? Well, that happened at pi over 4 or 5 pi over 4. Okay. So I have one like that on the, well, really two on the quiz, that they're really just kind of logic. Hey, where did that happen on the unit circle? Okay. So now I would like to focus on 5 and 6. Well, let's go to 5 first. So I have one on the test that is factorable right off the bat. Okay, so let's take a look at number 5 and why is it factorable? What do they both have in common? What do both terms, they have a cosine in common. So if you like the u substitution, or the, however you want to talk about changing out the variables, you could make that 2u squared plus u equals 0, factor out a u, solve each individual piece using our rules of algebra. So what I've done here is I factored out a u, don't forget that 1, set each piece equal to 0, and solve accordingly if you need to. This one is going to give us that 2u equals -1, or u equals -1/2. Now, once we get numerical components where it says u, or whatever our variable we chose, whether it says u equals or whatever, now put your trig back in. So this is where does the cosine of theta equal 0, and where does the cosine of theta equal to -1/2? So now it's just, what is your knowledge of the unit circle? The cosine is equal to 0 at 90 and 270. As radians, that's pi over 2, or 3 pi over 2. Cosine of theta, where is that equal to -1/2? The cosine is negative in the second and third quadrants. So -1/2 occurs at the 60s over there. So the 60 in the second quadrant is 2 pi over 3. The 60 down in the third quadrant is 4 pi over 3. Okay. So that's that. Let's see. I did not give you one like number 6, so cross that out. I definitely didn't give you one like 15. Cross that one out. And then let's do 4. 4 and 14 are almost exactly alike, so we'll cross that one out. So let's do 4 and 13. And then those are the types that are on the test tomorrow. Okay. Let's take a look at the difference between 4 and 13. Those are good options. Now, 4 has sines and cosines in it. That can screw things up. See how 13 doesn't? See how it's all sines? So we're going to start with 13, and then we're going to work our way back to 4, because they're going to be a good match for each other. So let's start with 13. That is a factorable quantity. If we let u equal to the sine of x, we get 2u squared plus 3u plus 1, which is factorable. Why is it factorable? Well, you can do slide and divide, but technically it's just 2u plus 1, and u plus 1 is the factorization. Now, why does that work? Well, 2 times u is 2u squared. First outer inner last, remember that from back in the day? 1 times 1 is the 1 in the back. But if you do innies and outies, I always think belly buttons for some reason. If you do the insides and the outsides, they should add up to 3, and they do. 2u's plus 1u is 3u. So that's the factorization. And then this part becomes very much now like number 5. Set each piece equal to 0 and solve. Once you get to the point where the algebra is solved, stick the trig function back in. And then ask yourself, where does that happen on the unit circle? Now, we didn't square anything, so we don't really have to check them. If you want to, you can. But let's take a look. The sine is 1/2 at the 30s. It's negative down in the bottom, so third and fourth quadrants. The 30 in the fourth quadrant is 7 pi over 6. And in the fourth quadrant, that 30, that pi over 6 is 11 pi over 6. Okay. The sine is only -1 in one place. That's 3 pi over 2. Okay. So ones where it's all the same trig function, you see, not bad. Not bad to do at all. Okay. Now let's compare 13 with number 4 for just a moment. We got a sine and we also have a cosine. But don't we know that cosine squared is the same as 1 minus sine squared? So the trick to number 4, to get it to be a problem like 13, is to take out the cosine squared and replace it with 1 minus sine squared. Now, everything is a sine at this point. Now is where doing a u substitution is a good idea. Let's let u equal the sine of theta. So we get 1 plus u equals 2 times 1 minus u squared. Okay. Going back to our rules of algebra, going back to algebra 1, algebra 2, if I ask you to solve that equation, there's some issues. The 2 needs to be distributed, so let's do that first. I personally always look at the highest power object and say, what side could I put that on to make it positive? I always focus on the highest power. So it's negative here. So if I move it, it's going to become a positive. So that tells me, let's get everything over to the left. So let's add a 2u squared to both sides. Let's subtract a 2 from both sides. And we get 2u squared plus u minus 1 equals 0 when in descending order. Guess what? That's a factorable quantity. Now you can use slide and divide. You can use guess and check. You can, try until you get it, okay? But anyway, the way that it's going to work, you would want the plus 1 here and a minus 1 here. Now let's do the FOIL real quick and why that happens. These two, the first should always make your highest power term. The last should always make your numerical term. The innies and outies, again, think belly buttons, should always sum up to the middle. So positive 2 and negative 1 makes a positive 1 in the middle. Okay. Any way you think of it, that's our factorization. And I'm going to solve each one of those equal to 0 over here. This one's easy. Just move that 1 to the other side. It becomes negative 1. This one, 2u equals 1, so u is 1/2. Put your sign back in. Now you ask yourself, where does that happen on the unit circle? In problem number 13, I told you that the sign is 1/2 at the pi over 6. So those answers for this one are going to be related to pi over 6 in the first and second quadrant. So that gives me an answer of pi over 6 or 5 pi over 6. This one, the sign is only negative 1, so it was very similar to actually that same problem at 3 pi over 2. So this is what your quiz looks like. This is what your quiz looks like. I'll zoom out here in a second. Please immediately turn this review in so you get your points on it. Yesterday we finished up the chapter 9 notes. If you haven't turned those in, please do that. Interims are coming. Please make sure that any late work you want to be counted in your interim is turned in by the end of school tomorrow. Okay, so turn that in. We're good to go. And now, if you could please, let's look at the 9-5 homework, okay? Because the 9-5 homework is, related, of course, to what we just did on the test. So I want to start with 9-5A. Here's 9-5A. And I just want to take questions from you about the 9-5A. So are there any particular ones from 9.5a that you're stuck on that you would like to see? Yes. Let's do number 2. Okay. So when all of the trig functions in the problem matches, that is a perfect substitution problem. I am going to take out all of the signs and I am going to make them u's. You can make them any variable you want. I'm just picking u's because it's related to something that happens in calculus. So it's good to get you to see that type of substitution. Anyway, so that's going to be u cubed minus 4u equals 0. Now, if you were asked in the algebra class to solve that equation, those are the thinkings you want to go through. Factorable, is it factorable is what you really want to ask yourself. So once it's equal to 0, check for a greatest common factor, check to see if it's factorable using any rules we got. They both do contain a u, so that would be my first step. Now, if you recognize that u squared minus 4 is factorable because it's the difference of squares, I do like to even show that. You can just set u squared minus 4 equal to 0 and solve and get plus or minus 2. You can do that too. I don't care. You do whatever you like to do. But in this case, I get that u equals 0, u equals negative 2, or u equals positive 2. And then, and only once we get what our variable is numerically, do we stick the trig function back in. So where is the sign equal to 0? Where is the sign equal to negative 2? Where is the sign equal to positive 2? Now, we learned some things about our sine and cosine function. Think about the wave. Think about how it wraps around the unit circle. The sine and cosine are always something between positive 1 and negative 1. Those ones do not work. They don't give us a darn thing. So if they're nonsense, just throw them out. But where is the sign equal to 0 is a legit thing. That happens at 2 places. It happens at 0 and pi. So the answer to number 2 is 0 and pi. Okay. And then number 4, move that sign to the other side of the equation, and it becomes almost identical to what we did for number 2. It's factorable, factor it, go from there. Okay. Okay. So that's number 2 on the 9.5a homework. Do we have any other ones that anyone is stuck on the 9.5a? Any? Number 8. Number 8, because of the fact that the only trig function is a cosine, it's a perfect substitution problem. So I'm just going to call it u. So that would be 2u minus the square root of 3 equals 0. Now let's think about how we would solve that. If I asked you in an algebra class to solve for u, you would add a square root of 3 on both sides. You would divide by 2. Only once you get your variable equal to a number, put your trig back in. And then you ask yourself, where does that happen on the unit circle? Well, the cosine is square root of 3 over 2 at, I always go to the first quadrant and find it first. It is square root of 3 over 2 at pi over 6, 30 degrees. The cosine is positive in both the first and the fourth quadrant because it's the x's. The x's are positive in first and fourth quadrant. So the answer would be pi over 6 or 11 pi over 6. Okay, so there's number 8. Any other ones from 9.5a? Yes. Oh, 7's a gross one. Perfect one to solve. Okay, so this is what we're going to do for this one. Get it equal to 0. See if there's a way to factor it. If we look, 4 sine squared of x times the tangent of x minus the tangent of x equals 0. Both of these terms contain a tangent of x, so it is factorable. Now, if you use variables for this one, you would have to use like u and w or u and z or something like that because there's 2 things in there. Yeah, so if you leave those trig functions in there, it would be the tangent of x times 4 sine squared of x minus 1 equals 0. So you can do it like that and then split it up. Where is the tangent equal to 0? Where is 4 sine squared of x minus 1 equal to 0? This is the difference of squares, so you can split it that way, or you can just solve it. You get the sine of x is plus or minus the square root of 1/4, which is plus or minus 1/2. So then where does this happen on the unit circle? Okay, so that is that. Any other ones on from 9.5a? Any other questions from 9.5a? There you go. I did not finish it. You got to ask yourself, where does that happen on the unit circle to finish out the problem? Okay, so that's 9.5a. That's 9.5a. Now let's jump. We're going to look at the 9.5b homework for a moment. The 9.5 practice we're not going to do, so scrap that. It will be out of the grade book sometime today, hopefully. So now let's go to the 9.5b homework. I gave you quite a few hints on that. So hopefully the hints were pushing you in the right direction, but maybe not. So I would like to answer any questions you might have about the 9.5b homework. Can anybody have any questions about that one? Yeah, let's do number 5. Now, number 5, it was one of the ones in the review. If you don't square both sides, sorry about that. If you don't square both sides, you can just think on the unit circle, where does the cosine and the sine match at the 45s? Okay, so the answer to this, I didn't think about that yesterday, but you can just go, where does the sine and the cosine have the same value on the unit circle? And the answer would be pi over 4 in the first quadrant. They're both square root of 2 over 2. They're both negative square root of 2 over 2 in the third quadrant, which is 5 pi over 4. So logically, just kind of thinking where they match is probably the easiest way to go for that problem. I initially was going to square both sides and use a Pythagorean, and it was just becoming a little convoluted. You didn't necessarily have to do that. I was overthinking that one for sure. Any other questions about 1 through 8? Yes. Number 7. Okay. So my suggestion for number 7 was to replace the tangent squared with how it was related to a secant squared, because there's a secant sitting there without a square on it. Well, tangent squared is the same as secant squared minus 1. So what we're going to do is we're going to take this out, replace it perfectly with that. There's nothing in front to distribute, so you can just lay that in there. And then don't forget, this has to join it. So we would have plus the secant of x minus 1 equals 0. Now, once you get all of the trig functions matching, let u equal that trig function. And then let's put it in descending order. And let's see if it's factorable. Well, they were nice to us. They let it be factorable. And we get, in factored form, u plus 2 and u minus 1. Now split it up to 2 pieces. Where does u plus 2 equals 0? Where does u minus 1 equals 0? That is at -2, and that is at 1. Only once you get to the point where you're at a numerical value do we put the trig function back in. Secant of x equals -2. Secant of x equals 1. Now, I don't know about you, but my brain does not go back on the unit circle for secants. But the reciprocal of a secant, I know. What is the reciprocal of a secant? What is the flip of the secant? It's the cosine. So what I'm going to do to make this more accessible in my brain on the unit circle is I'm going to think, oh, well, this means that the cosine is the flip of that. This means that the cosine is the flip of that. The flip of 1 is 1. The flip of -2 is -1/2. I'm just using the reciprocals. Now I can go back on the unit circle. Now my brain works a little better. Where's the cosine negative? Oh, the cosine's negative in the second and third quadrant. Where is it 1/2? At the 60s. So the 60 in the second quadrant is 2 pi over 3. The 60 in the third quadrant is 4 pi over 3. Where is the cosine equal to 1? That only occurs in one place, and that is at 0. You could put the 2 pi, but the instructions don't put a bracket on the 2 pi, so you don't have to put the 2 pi. You shouldn't include it. So that is that one. I think we have time to do one more. Number 6. Let's do that one. My hint to you yesterday was you can factor out a cosine. Okay, so let's use that tactic right off the bat. So well, I'll do it under here and then I'll continue to the right. If I take out the cosine here, I'm left with radical 3 times the tangent. If I take out the cosine here, don't forget the 1. So that's very important. Okay. Then over here to the right, I am going to split that up. Where's the cosine equal to 0? I'm ready on the unit circle for that one. But this is the gross one. So let's talk about how do we solve radical 3 tangent of x minus 1 equals 0. Well, solving it isn't the bad part. That's not a hard problem to solve. You move the 1 over. You divide by radical 3. Well, I'm going to show you a little trick. Anytime you see radical 3, always think on our unit circle that has to be related to the 1/2 radical 3 over 2 problems. You know, one of them is 1/2, one of them is radical 3 over 2. The 1/2 is up here. The radical 3 over 2 is wherever the radical 3 is in the problem. So wouldn't this be your sine? And this would be your cosine. So if the radical 3 is in the bottom, the radical 3 over 3, I'm not talking rationalized form. I'm talking about when we first start in the problem, if we don't rationalize it, where's the radical 3? If it's in the top, our sine is radical 3 over 2. If it's in the bottom, our cosine is radical 3 over 2. So that is the point radical 3 over 2 1/2. Okay. That occurs at the 30s. Where's the tangent positive? First and third quadrant. So if you get the 30 in the first quadrant, you're halfway there. Down in the third quadrant, they're both negative, which is okay. And that is 7 pi over 6. 210. Okay, so that is that. So just some little reminders. You should have turned in your chapter 9 note sheet. 9, 5, A and B homeworks are due tonight. Turn in this review because you just did it and you just got points. Turn that in. Study for the test. Look over your unit circle. Okay, so that is what's going to be on the quiz tomorrow.